So
Do you know what is that error, Nilima?
yeah, I'll show that.
Okay, okay, thank you.
Yeah, just a minute. Actually, this is the error. Here, when we try to run this container on this, then it is showing that this network test 3, this image is already in use. This is because I actually deleted the network and the container. But what will happen is we have to, I'll just show the command. We have to first disconnect the network and then only that disconnect the container. Sorry, we have to disconnect the container from the network using the command disconnect. Prune will actually remove the networks which are not being used by the containers. But we have to disconnect the image, and then only this network will be deleted. Otherwise, it will not be deleted. So I didn't execute this command while I was preparing. So it is showing that this image still exists. That's the error we got in yesterday's session.
Okay.
So we have to first remove and then we have to execute this network prune. Then only this network will be deleted.
Okay. So the network prune will delete all the networks that are not in use.
That are not in use and they don't have any containers running on them.
Okay. Yeah.
This network prune will be deleting only the networks which are like in isolation, which are not being used, and which are not being used by any of the containers. And this will not even delete the default networks.
Okay. Okay. Yeah, sounds good.
Okay.
Anybody
So
have
this
any
is
questions on that? No questions? Okay, yeah, that's good. Yeah, you can go ahead. You can go ahead to next topic, Nilima.
okay. I'll be discussing about Kubernetes today. So basically, I'll just these are the components I have documented this, and Kubernetes is like it's an open source. It orchestrates the containers, which is and by deploying and by scaling, it maintains the health of the containers. This is an open source, which is by Google. And there is also a Docker Swarm, but Kubernetes is widely used. And this Kubernetes is like it has a cluster which is like master, and it will be having nodes. One will be the master, and the remaining will be the worker nodes. So I'll just show the components here. This is the basic architecture of the Kubernetes. And the CLI is the kubectl. Kubectl is the command line interface for Kubernetes. When we execute commands like kubectl get nodes, then this command line interface will be interacting with the API server, and this API server will be then contacting the control manager. This control manager is like it's completely the management of the class master node here, and this manages the nodes, worker nodes by when we deploy a service or through the deployments, it will be managing the worker nodes. So these are the components in the master node, that is the API server. This API server is like the API call when we execute this command through kubectl or the command line interface. Yesterday we learned that there will be also an user interface. So through this also we can execute the Kubernetes commands, and the commands will be here. You can see this kubectl will contacting the kube API server, and this will in turn contact the control manager. And etcd is nothing but all the data which is related to this master node will be stored in this etcd. It is like the backup backup for the master cluster. And the scheduler is like it will be scheduling that what pod should be run on what node, depending on the circumstances. Like if we mention some labels, and the same label should be on the node as well, then only that pod will get deployed on the node. Such things are maintained by schedulers. These are the basic components which are on the Kubernetes master. And coming to the Kubernetes nodes, worker nodes, kubelet and kubeproxy, and Docker. Docker is for maintaining the runtime of the container. It can be also container D for some clusters, and it can also be Docker. These both maintain the runtime of the containers in the pods. And there are also services in the Kubernetes cluster, which are nothing but load balancers. And there are also other services like uh, a cluster IP mode service and node port mode service. There are also other type of services depending on what the application requires. Then that type of services will be used. And this load balancer service is what maintains the traffic, and this will this will be looking into the nodes, and if one node or if one container runtime is down, then it will be scheduling that node to another scheduling that pod to another node, so that always the application or the microservice or whatever is running in the pod will be always up and running for the end users. So deployment is nothing but if one we can set the replicas for the pods. Like if we have an application, okay, let me first show you an application. So let's take this application. So this is a basic application where it will be having different microservices. These all are microservices. And this search is also a microservice. This sale is also microservice. Everything, they build a container and then deploy that containers as pods onto nodes that will be running always, and that will be available to the end user. So coming to this, generally in Macy's, what we do, like women shop a lot, I think. So this woman microservice might need more number of servers, and the traffic might be more for this microservice. So they need more servers, and every time the traffic increases, one node might be down, one pod might be down, and the other pod replicas, when we set the replicas, the other pod will go up and running. And this is also a search is also a microservice, and this might need more servers compared to other microservice, because when we go and open an application, we just go to the search bar and search for whatever we need. So this might need a number of servers to maintain this application or microservice, to always keep it up and running. Sorry. And let's take an example of this sale. This sale might not be there always, only like it might be there for some days, like if it is a holiday season or something, then the sale will be coming up. And during that time, this sale application will be having a lot of traffic. And during other days, it might not have that traffic. So this is when Kubernetes, when the traffic is more, it will be scaling up. And when the traffic is less, it will be scaling down the containers. So that is the basic and the main purpose of using Kubernetes in deployments. And so these are the components. And this kubelet, kubeproxy are present on the worker nodes. This kubelet will be contacting the master node through the API server. It will this kubelet will be contacting, like if one container runtime is down, if one container is down, then it will be contacting the master through the API server. This kubelet is responsible for giving the information from the node to the master. So this kubelet is a very important component of the node. And kube proxy is also very important. It will be responsible for maintain networking. Like this, there is a networking like it for the for the containers to communicate in between them, and for one container to communicate with different container on another node. Then this kube proxy and the networking are mainly responsible. Okay. So, okay. And I have written everything like briefly here, all the components. And this kube control manager also will be having these all together are called as kube control manager. These are again, this kube control manager will be having these as its subcomponents maybe. So this is a node controller which is responsible for noticing and responding when nodes goes down, and it will inform the kube control manager. These all together are known as a kube control manager. This kube control manager is responsible for contacting nodes and maintaining the health of the nodes. And there is a service account controller which controls the namespace. Namespace is nothing but when we create pods on the cluster, then we can put everything by putting on we can name them according to some logical naming, and we can put some containers in that namespace. Like if there are multiple teams working on a cluster, and we can like a prod namespace or dev namespace, and we can put the pods in that. That is nothing. It is controlled by a service account controller. And there is also a cloud control manager. This kube control manager is always necessary, but this cloud control manager is only necessary when we run this in cloud environments. If it is on-premise environment, we don't need this. We just need the kube control manager. And again, this cloud control manager is also made up of these three subcomponents like node controller, route controller, and service controller. And these are the components I have discussed about. Yeah, that's it for the uh, Kubernetes concept and cluster and architecture. Let me show you of the lab. Here, we will be like building a cluster using KubeADM. KubeADM is a kube administrator by which we will be installing or initializing the cluster on the master node. For this, we will be needing 3 servers. This needs like Ubuntu platforms to run this commands. So I'll be just telling you the commands and how it works. So this we have to connect to 3 servers first using the public IP address. And this, what it actually does is, this will show us the content, and we are piping this content onto this container d dot configuration. So these are overlay and BR network filters are the kernel modules which are required by the container D. Container D, here we are using container D for the runtime of the pods. We can use also Docker. So whatever we do this, whatever configuration, it should be when this starts with EOF, it should be ending with EOF, and this will concatenate the content here on the terminal. So those are the kernel modules which are required by the container D. And again, we have to we are setting like some configurations, right? So we have to do this mod probe overlay and mod probe BR net filters, because whenever we restart the server restarts, then these modules will be loaded automatically. So for that, we will be using these two commands. And this is also the network configuration. We have to set the network configuration, which is required for the Kubernetes networking. These are the configurations which has to be set. And we are changing the configurations, right? So we have to apply them immediately. So this sudo ctl and system, this command will read and apply them immediately to the configurations. Next, we have to install containerd. apt-get is the package manager for Ubuntu. So we are updating and installing containerd. Okay, and next we are default configurations. These are the configurations which are required for the containerd. We are actually making a directory in this folder. And again, this configuration, this default configuration, we are piping it over and we are transferring that to config.toml here. So this default configuration will be applied here. So this configuration, as we are again setting up the configuration, we'll have to restart so that these configurations will be in up and running. So this is the command which we'll be using for that, sudo systemctl restart. And we can just check the status of the containerd, which will be up and running after this. And sudo swap off is like, I think this is whenever there is a restart or whenever there is there is again a reboot of the system or the servers, then all the files or the configuration files we set before are not changed by default. So whatever configurations we set previously are maintained. So I think that's the use of this command here. Yeah. And again, these are the dependency packages which needs to be installed. apt-get is like, through this we are installing the dependency packages. Then we have to download a key to add the repositories here. So here we downloaded curl. So curl will be getting these keys here. And after that, we have to add the Kubernetes repository here. And again, we have to update the servers. This has to be like done on all the three servers. Whatever one should be the master, 2 or 3, any number of worker nodes can be there. All these commands should be executed on all the servers. And after that, we have to install the Kubernetes packages, which are kubelet, kubectl, and kubectl. These are the packages we'll be installing, and all the packages should be of the same version. As we have changed the configurations and the versions are set, we don't want to change the configurations or versions by default. So we have to put a hold to that changes. So we'll be apt-mark hold kubelet, whatever packages here we have installed, we have to hold them, like they don't get updated automatically. So this is the command. And until here, we have to be doing all these commands on all the nodes or all on the servers, how many servers we want to be as worker nodes, and one master node. So after that, this command should be initiated only on the master. So which server we assume to be a master, then this command should be executed only on the master. We are just initiating the cluster using the kube administrator. And this pod network cider is used by the Kubernetes network overlay, which we discussed yesterday. Like Kubernetes should have a network overlay for communicating between two containers which are on different nodes. So for that networking, this CIDR block is required and the version of the Kubernetes. Then the cluster will be installed, initialized. And here we are actually setting the system configurations by in kube config has to be set on the master node, because this kube config will be it will be responsible for communicating with the cluster. So this cube we have to set the system configurations here. So when we next we can execute the get nodes command, but we will not be getting any nodes because there is no network and we didn't connect the master and the worker nodes, because there was no authentication between the master and the worker nodes. So they has to be connected. Then only we'll get we can execute this command. And there is also no overlay network installed, so we have to install the network. It can here we are using Calico network add-on. So this is a command we'll be using, and this is a calico.yaml file which is present in this URL, and we will be applying this file. So this network will be set, and when we now again if we type kubectl get nodes also, we cannot be getting the nodes because we didn't authenticate the master node to the worker nodes, right? So we have to create a token, like for the authentication we have to create a token on the master node so that it will be connected. We can it will be there will be a token generated, and that has to be copied onto the worker nodes so that these master and the worker nodes are authenticated. Here, while setting the system kube config system configurations here, then we will be getting the command token, or otherwise we can just kubeadm token create. We can just use this command to create the token, and that command we have to copy paste on both the worker nodes. Then there will be authentication created, and when we execute the command kubectl get nodes, then all our nodes will be ready and in a status of ready. Yeah, Vishnu.
Any questions from anyone? Nilima, can you make me host actually?
Okay.